Welcome back. This is the third video recording of the lesson from IM2 week 2 lesson. We've just learned how to sketch quadratic functions, and now I am going to show you yet a simpler way to graph quadratic equations. So we are going to start off with y is 1x squared. This is what we call parent function because this is the most simplest version of the quadratic equation. And if you look at that, where we start is 0, 0. When x is 0, y is 0. And that's where we are going to start. This is where we start from. That's the vertex. When x is 1, 1 squared is 1. And if you plot that, how we got there from the vertex is 1 unit to the right and 1 unit up. 1 up because 1 squared is 1. When x is 2, y is 4, which is 2 units to the right and 2 units up, or 4 units up, I'm sorry. Why 4? Because 4 is 2 squared. When x is 3, 3 squared is 9, so we moved 3 to the right and 9 up from the vertex. If we were to do the left-hand side of the y-axis, this time, instead of going 1 to the right, this is 1 left and 1 up, and 2 left to 4 up, and 3 left and 9 up, so on and so forth. Okay, so that is general pattern for y is x squared. We're going to start with that, and then we are going to move on to what if the vertex is not at the origin. Okay, so if you're starting with when x with this vertex form, we can straight away find what the vertex is. Vertex is going to be 4, negative 2. 4, negative 2 here. Okay, so again, we're going to start with 4, negative 2. And it's the same pattern. So when I moved 1 unit to the right, I went 1 up. 2 units to the right from the vertex, I went 4 up. And 3 units right from the vertex, I went 9 up. And when I went to the left of the vertex, same thing, but this time we're going left, 1 up, 2 left, 4 up, and 3 left, and 9 up. Okay? So you might be asking, what's the advantage of using this method? Well, this is simpler in many ways. There's no calculations involved. And it is especially handy when you don't have x-intercepts. So some functions will not cross the x-axis because it's not factorable. In that case, it will be a floating parabola, in which case it does not, there are no x-intercepts to figure out from. And plus, this is just way quicker in some ways. And also, if the x-intercept is present but it's not a whole number, then this method is going to be much easier to plot. Alright, so how would you modify the instruction if a is negative 1? If a is negative 1, remember if it's negative, then the parabola is sad because parabola is negative and it is going to have a sad face, so it's going to be opening downwards. And so, but it's basically the same process, but where I went 1 right, and then instead of going 1 up, I am going to go 1 down. And 2 right, 4 down, 3 right, 9 down. And so that's basically the pattern. Instead of going up by whatever the y units, we're going down. Okay? I would like you to try to solve this. Use the counting method to graph this, and if you have graphing paper, you should be using this now. Okay, so the first, and you have 3 minutes. I gave everybody 3 minutes. You start off with finding the vertex. Vertex in this case will be 3, negative 1, and then use the counting method. This only works when a is 1 or negative 1. Okay, I would like you to actually start with x plus 5 whole squared minus 7. And then do this problem as well. Okay, please pause the video and do the problems now because I am showing the answers in 3, 2, 1. Hopefully you've graphed this and gotten this graph. Awesome. Let's move on. Okay, a new vocabulary. We always start graphing from the vertex. Even if it moves around, even if the vertex moves around, this is still the easiest way to graph. And vertex is also called the locator point. Why? Because that's how we locate where the starting point will be. Next up, using this method with the other two quadratic forms, how can we modify this when we are dealing with factored form or standard form of the equation? Well, factored form, we do the same thing. We need to start off with the vertex. How do we find the vertex from the factored form? Well, we know the zeros straight away. 3 and 5 are my zeros, and we know that the vertex is going to be halfway between those two zeros. So, again, to find the vertex, we are going to average those zeros, 3 and 5, and divide by 2, which is 4. We know the x-coordinate is 4. Then we substitute that back into the equation to find the y-coordinate of the vertex, and substitute that back in, and we find y to be -1. Now that we found the vertex, we go from 4, -1 here, and I just checked that a is 1, so that means I am going to go 1 to the right and 1 up, put a point there, 2 to the right from the vertex, and then 4 up this time because 2 squared is 4. And then 3 to the right from vertex, and this time 9 up, because 3 squared is 9. Okay, also, some other trick is to draw a line of symmetry. Because parabola is always going to be symmetrical, we know that we can just reflect it back on the line of symmetry. We don't even have to plot the other. We can just find the points equidistant from the line of symmetry. And then we have those points, and now we just need to join those together. Voila, we're done. Okay, now I'm going to show you yet another method that's going to make this even easier. Okay, so if you look at this table of data here, you can see that how is x changing? 4, -1 is my vertex. 4, -1 is my vertex. How do I know? I match up the y values. The only one that is alone is this one. 4, -1 is my vertex. From my vertex, x value is increasing by 1. Y value is initially increasing by 1. And then from here, from 5 to 6, x is increasing by 1 again. But this time, the y value is increasing by 3. And when x increases by 1 more, this time y is increasing by 5. Okay, do you see the pattern? When x increased by 1, y increased by 1. But next, when x increased by 1 again, y this time increased by 3. When x increased by 1, the next time, y is increasing by 5. So this stepping method helps you just plot it and then go from there instead of going back all the way to the vertex. Just going from here, and this time 1, 3, and 5. And what do you suppose the next increase will be? I hope you said 7, because there seem to be a pattern of 1, 3, 5. Okay? So we are going to use that method. And when we're going negative, again, it is the same thing. It's increasing by 1, 3, and 5. Same thing. Okay. Great. So we know what to do when a is 1 or -1. So you start at the locator point, which is a vertex, and then count left to right by 1, and then up or down by 1. And the next will be count 1, left to right by 1, and then up or down by 3 this time. And the next will be up and down, left and right by 1, but up and down by 5. So we keep increasing. It's just odd numbers increasing up. Okay? Alright, so the standard form. If you are given the equation in standard form, how do we graph this using this method? Well, do we know how to figure out the vertex? Yes, because we know the formula -b/2a. We've talked about how we derive that. So then we quickly plug those numbers in. That's b is 4 here, so it's going to be negative 4 divided by 2 times 1. A is 1. So that simplifies to negative 2. Negative 2 is the x-coordinate of the vertex. Now substitute that back into the original equation to find the y-coordinate, and you get the y to be negative 6. So negative 2, negative 6 is my vertex. And then from here, I do the same thing. Okay, because A is 1, I am going to use the same method. 1 up, 1 to the right, 1 up, 1 to the right, 3 up this time, 1 to the right, 5 up. And I am going to use the symmetry to plot the other points on the other side, and then join those points together, and we are done. Great. So I am giving you 2 problems for you to try, and this is one in factored form, one in standard form. You have 3 minutes to try this, and please pause the video and try it now. The answer will be in 3, 2, 1. Here we go. This should be the plotting of the graph that you should have had. How are you doing with it? If you need help, I'm available for help during study hall, so come see me. Alright, so now we're going to speculate. How would the 2 graphs of these 2 equations be different? So far we've just dealt with when A is 1. What if A is not 1? Say 3. How would that be different? Well, let's look at the first graph. A x minus 2 all squared plus 1 here, and x minus 2 all squared times 3 plus 1. So this portion is exactly the same, and this portion is exactly the same. The only difference is we have 3 in front of the parentheses, or the A value is 3 instead of 1. The right graph looks like this. Notice that the vertex are both the same. It's 2, positive 1. Okay, so if I was to plot those 2 together on top of each other, notice the vertex matching up. But where the green is when A is 1, where x increased by 1, to the right, the y only increased by 1. But for the purple graph, this time it increased by 3. When x increased by 2 from the vertex, the y increased by 4, because 2 squared is 4. But for the purple graph, it increased by 12, which is same as 4 times 3. There is my 3 here. Okay, any guesses when x increased by 3? Well, the y for the green graph increased by 9, because 3 squared is 9. But then for the purple, it's 9 times 3, so 27. So it increased by 27. So that's what would happen. So when you have A is not 1, but 3, you actually need to change the vertical change by whatever that factor is. If it's a fraction like a half, then you actually need to halve it. So that 3 is the A value. They both have the same vertex, and the blue graph is vertically stretched by the factor of 3. That's what we say, because the blue graph is skinnier, as it's almost as if you just pulled, you put your two hands that you're holding over here and then holding at the vertex and just pulled apart. It just made it stretched out. Okay, and hence A is called the stretch factor. Okay, we are ending towards the end of the lesson. What did we learn today? We learned the alternative method of graphing by counting from the vertex. Okay, this was really handy. And then we also learned the stepping method, because that made it even easier. And then finally, we also used the fact that it is symmetrical. Parabola is always symmetrical, so that you can just reflect the points. Okay, so this is the end of the lesson. If you have any questions, please come see me during study hall. I think you should be able to go on to your homework. Please get to it quickly. Take care. Bye-bye.